I thought I figured it out. Perfect temperature, steady heat, and a constant airflow. My tempeh came out quite decent, maybe even good, but somehow it was a bit dry on the edges. So I was not satisfied with the result. It was good, but not good enough for me. So in this video I want to show you how I went from this okayish tempeh to a perfect tempeh. Let me start with what I had in version 1. If you didn't see the video, go ahead and watch it after this one. It was nothing fancy. It was a plastic box, horizontal, the airflow was going through, there was a heating element, everything was fine. It was glued together, it looked ugly, but it worked. The whole thing was powered by an ESP32. If the temperature dropped below a threshold, it started heating. If it got too hot, it started cooling it down. Because you have to know that tempeh produces its own heat when it starts to ferment. So you don't want to add more heat, but you want to cool it down. I did a few batches in this version and it worked quite well. I did chickpea tempeh, I did soy tempeh, and all of them tasted quite good, but as said, quite dry on the outside. You could call it a success, right? Not really, because as you see, it doesn't look good. The tempeh was okay, but the whole box doesn't look nice in the kitchen. The problem was also that the fan was constantly running to keep some airflow. If I stopped the constant airflow in the plastic box, the humidity went too high. If the fan was on the lowest speed, on the 12-volt fan, it was too much and dried out the beans. A vertical setup is not ideal. Also, I tried to experiment with other alternatives of a plastic bag because I didn't want to throw a plastic bag in every batch. So I printed these tempeh boxes. There were free open source boxes and they look quite nice. They have holes in it, so it won't mold. But you see, after 2 rounds, the whole thing warps. It breaks. Here you can see it braked already. So the heat was too much and it started to warp the whole box. So maybe I was using the wrong filament. I used PLA. I think it's just not made for that. Unfortunately, I have to go back to doing it in the classic way of a plastic bag with some holes, but it just works better than these 3D printed boxes, so I have to throw them away. Now I have the problem of the fan that was constantly running. In a vertical box, the heat automatically rises, so I started to create some draft boxes, how I could build it. My first version of the box is a card box or cardboard box. So I started how it will look like. You can see the size. I checked if it fits in the kitchen. And as you can see, the tempeh will be vertically stacked. And I started to add the area where I want to have the fan. And in the bottom, I want to have the holes. So the fresh air will be coming in from the bottom, go through rises from the heat, and the fan will be pulling it out if it's too hot, or naturally if there's no fan running, the heat will still rise and go through the holes of the fan. So yeah, first version, cardboard box, and then I started going on Tinkercad and draw the whole version in precise measurements with the size of the wood to create the measurements for the sawing later. Also, people said in the last video that the DHT11 is not really reliable, so I had to exchange it because I got a few unreliable readings. It was not precise enough, so I switched it for the BME 280. It's a pretty precise sensor. It also costs like €2, $2.50, and it is really reliable. So version 2 is not just an upgrade, it's a redesign. I used the same code, I used the same components, but in the end I started from scratch. I built the whole box from zero. The new box will be out of plywood from the hardware store. It's nothing fancy, but it's very simple and big enough to host 300 to 400 grams of dried beans. So in the end I will have per batch half a kilo of tempeh. That's more than enough for me for 1 week. Sometimes I don't even need that much, so I just freeze it. So here we have the final box, the version 2. I'm a cook, I'm a nerd, but I'm not a builder. And as you can see, it works, it's fine, but it's not perfect. With some sanding, some grinding, it looks more or less fine. As you can see, this is not perfect. Here, the edges are not straight, but in the end, that's why it's DIY, right? I added magnetic closing, so if the door is closed, it's pulled on magnetically. And the brain is, as last time, an ESP32. it sits below here. It's the same code as last time, except that this time I also have a humidifier. And as said, I upgraded to an BME 280. You can see it back there. This is also the humidity generator. So you put it into some water and it generates the humidity quite well. The heating pad is a bit bigger this time. I put it above the holes, so the air have to travel around the heating element to give it the perfect airflow. So the heat will rise, as said, from the bottom to the top, and it will go around the heating element, will go out in the back. And if the fan is off, it still rises and goes out in the back. The fan is on a bit off because the cables were too short. But as said, this will be fixed at some point. But most importantly, I designed my own PCB. This helped me quite a lot because before I just glued everything together and soldered everything together. That was very, very annoying. This time it's a PCB, you can screw everything in. The cables will be screwed in, the parts will be just soldered on it. And it's very straightforward. I can just connect and disconnect the parts. So for example, if I want to disconnect the rotary encoder, it's just one plug. And if I want to connect a new one, it's very straightforward. Same goes for the power. It comes in through that board, 12 volts. In here, it will be stepped down. It will be stepped down to 5 volts with this board and then goes back into the ESP. The ESP is running on 5 volts. But everything else will be driven by 9 to 12 volts. It will be triggered with these MOSFETs. So the humidifier, the heater, and everything is in the MOSFETs. From the logic part, it's very straightforward. If the humidity is too low, the humidifier turns on. If it goes too high, the airflow will turn on, the humidifier will turn off. The heating will turn on if it's too cold. If it's too hot, the heating will be off and the fan will be on. So it's really, really straightforward. It has a few thresholds. You can adjust it. And yeah, that's basically it. It's very straightforward and it produces perfect tempeh every time. So I run 3 batches now with this box and it is way, way better than before. It produces the perfect tempeh that I was looking for in the end. So lessons learned, the vertical way of creating the tempeh is way better. It produces way better tempeh for me at least. If you are interested in the parts, I will link them all down in the description. In the repo, you will find the PCB. Doing your own PCBs, I highly recommend. I ordered my PCBs from JLC PCB. It is not sponsored. It was so cheap that's just not worth it. It cost me €4 to get 5 of these PCBs. As you can see, they are blank. In black. I put on all the components here, the holes, and yeah, I highly recommend creating your own PCBs because it makes your life way easier. And as said, €4 for 5 PCBs, that's basically a steal. And it was including shipping, so I think I paid like €2 for the PCBs. The rest of the parts I will also link down in the description. It's mostly the same as last time. It's a 12 volt fan, it's a heating element, the BME 280, a few cables and a rotary encoder with a display, the ESP32. And the code will be also in the GitHub repository I will publish and you can just build it yourself. So let me know down in the description what you think about the version 2. If you build it yourself, if you have any suggestions how to make it even better. At the moment it's pretty good, but you can always make something better, right? With that, I wish you a great rest of the day. Thank you for watching. Leave me a comment, give me a thumbs up or subscribe. It helps the algorithm. It doesn't cost you anything. Have a great rest of the day.